Hey guys, welcome back. So today we're working on this 5,000 watt Powermate. This one was found on Facebook Marketplace by a local subscriber who picked it up on our behalf. This was too good of a deal to pass up. The seller was only asking $85, and according to the listing, it doesn't need a whole lot to get up and running again. Supposedly this was running about 2 years ago. And to get it running again, all we need to do is replace the battery, replace the missing pull cord, and clean the carburetor. So whether that is the full extent or not, at 85 bucks, it's hard to go wrong. So let me get you set up a little bit better and get going on this. All right, first things first, let's check the oil. This engine, I'm not sure if it's locked up or not. The battery's dead, the pull cord's missing, so those are kind of red flags. But there is a low oil sensor on here, and it appears the oil is filled properly, and it does not smell contaminated with fuel. So that is a good sign. And according to the date, this battery is about 9 years old, so the seller likely is correct that we're going to need a new battery, but let's just check if there's any voltage at all in here. And surprisingly, not completely dead. We're at 6.86 volts. So yeah, there is potential that this could charge up. But for now, I'm just going to pull this one out. I have a brand new one we'll put in its place, and then we can test the electric start. See if the engine turns over. And on this battery, we have the positive on the other side, so this lead doesn't fit. We could turn the battery around, but I think it's a little easier if the terminals are facing out. So we can just reroute this wire over the stator, and that should give us plenty of slack to work with. And we'll route the negative the same way. All right, good. No sparks, so no short in the system. And this machine is pretty unique in that, it's a 9-horse Vanguard with electric start. Don't think I've come across one, on a generator at least, that has electric start. All right, let's try the electric start. Ooh, it works. But something in here sounds really bad. So let's actually get the starter recoil off and just rotate the engine by hand and see how it feels. That one's stuck. And the starter itself actually looks fine. The rope is still on it. It looks like it just broke, you know, where the handle was attached. But yeah, this is not good. I cannot rotate this by hand. So, yeah, something's not right. So I think we need to keep digging here. I don't think it's a problem with the cylinder, and I just say that because the grinding noise that I was hearing was kind of in the flywheel area. So, you know, potentially the starter Bendix is a problem. You know, maybe we have a critter nest, or potentially the coil is hitting the flywheel. But as it is right now, you know, I can barely get that to move. Well, in theory, to get the blower housing off, it's not a big deal. It's just a few bolts going around, and then this should come right off. The issue is that this plastic piece and the airbox, they're actually in the way. So we have to pull those first before getting to the bolts. And I'm thinking before even tackling that, you know, the tank, it's kind of in the way. It does sound like it's full of old fuel. So I'm thinking, let's actually start there. Let's drain the old fuel out. We'll just get the tank out of the way, and then we can move on to gaining access to the bolts to pull the blower housing, which is not fully secured. So yeah, we are actually missing a bolt right there, or rather it looks like it's broken off. And the fact that the starter recoil rope is broken too tells me that someone knew about this problem. You know, they're likely trying to pull start it and broke it, and then tried to remove the blower housing and didn't get very far. So yeah, not off to a good start. You know, hopefully we don't break any more bolts, but let's, again, start with the tank, and then we'll move on to that blower housing. And regardless, we do have to pull the tank. Just looking at this bushing, it has a big crack in it, and the valve is pretty rusted up. So I was gonna check to make sure it was off. And it does still spin, but it was left in the on position. So yeah, not a good sign. You know, likely that carburetor has issues. So it's not that surprising. For 85 bucks, yeah, we have more issues than we were led to believe. You know, the interesting thing is that in the same listing, he made it a point to say the engine wasn't locked up, which technically is correct. It did turn with the electric start, but you know, the fact that you can't rotate it by hand, you know, that probably should have been mentioned. And a little bit of fuel in the line. And it is water contaminated. So yeah, you see how it's all cloudy? So hopefully the tank isn't like that, but given this was stored outdoors, you know, all that sloshing around in there, that might not be fuel. That could be all water. So place your bets. Are we going to have fuel in the tank or water? I'm hoping for fuel. You know, at almost $5 a gallon, if we have 4 gallons in the tank, that would make this $85 generator closer to $65. So let's open up that valve. Well, the valve's open and not a drop came out. So yeah, I can't say I'm that surprised. I'm going to try to blow through this backwards. And no, it's actually building pressure. So that is plugged solid. I think we're going to have to drain this one from the top. Yeah, I guess the good news is it is a plastic tank, so we don't have to worry about rust, but I can tell already from the color. I think it's been more than 2 years since this last ran. You know, the fuel, not a good color. There's definitely a lot of water in there. Actually, I would say about 90% of what's come out is water. We also have a chunk of something. Looks like plastic. So I'm not sure I want that running through this pump. It might get stuck. Yep. There's a couple chunks there. Let's see if we can get those out. I think that's actually the underside of the fuel cap. There's a seal there. So yeah, that must have broken up. And we're seeing those pieces come out. Now it does look like all fuel coming out. So the water line, it's right there. Here we have another big chunk. Get that out. And thankfully there is a fair amount in here, but I don't think we have much more than maybe 4 or 5 liters. All right, we'll set this one aside and get another bottle. And in total, we got about 6 liters of fuel, maybe a little bit less if you discount the water. You know, all the fuel that came out, though, it is hazy, so this is going to have to sit for a day or so to let any water in the fuel precipitate out. And the fuel on top actually is still good, so that can be poured off and filtered in a coffee filter or maybe through a towel. You know, the water, being that it's on the bottom, you know, that can be left behind and the fuel reused. I think the main issue on this machine, well, besides the engine, is just going to be getting the fasteners out. There's a healthy dose of rust pretty much everywhere you look. Yeah, definitely pretty crusty in here. So I'm just going to spray down pretty much every bolt that I think we might need to mess with. Even the linkage here. I mean, this is the adjustment for the engine speed. You can see just rust on all these fasteners. So yeah, hopefully we don't need to take all these out. But I think to get the plastic piece out, we do need to remove, you know, this one, that one, that one, that one, and there's one over there. Not to mention the ones on the engine holding the blower housing on. So yeah, this, we're going to have to tread lightly. You know, breaking a bolt that goes into the engine block, never a good thing. See if the throttle is stuck. Nope, that actually moves. Not sure what that is. It is surprising that that is not stuck. Although the adjustment for the throttle almost stuck, kind of like the engine. So let's see, next I think we need to detach right here. That one's not budging. Let's try this one. All right, that one moves. That one does not. And I guess technically we can probably leave this on here for now. So yeah, to get the plastic piece off, we just need to pull this plastic off the adjustment for the throttle. And I think this will slide out. And I did end up disconnecting the battery because we have full-time battery positive coming up to that switch. So luckily that came off pretty easily. You know, these wires, I don't think we need to disconnect. Not that you can see them. Let me turn you a bit. So I think we can leave them connected for now. And just set this kind of off to the side. And next we get the airbox cover and base off. And then, you know, we just have the bolts holding this in place. So we're going to pre-soak those. And let's see if there's any surprises in here. These screws, they were kind of loose. Yeah, looks pretty clean. Filter's in decent shape, so that's a very good sign. Okay, and we've taken apart what we need to, and I guess this is what I was thinking of. This bracket connects up to the governor linkage up above, so we do need to remove some fasteners eventually to get this carburetor off, assuming it needs to be cleaned, which I would say is a good assumption, but for now we do have access to what we need. So let's get those bolts removed and pull the blower housing off. That one was surprisingly easy. How about this one? Nope. I'm shocked that one came off. So we're actually broken up here. That bolt isn't removed. So yeah, blower housing not in great shape. And this one up here equally appears to be damaged. So someone at some point, I think, forced this off. And nothing obvious, although I say that, in the Bendix, it's engaged to the flywheel. So I think that might be the issue. Yeah, it's not supposed to be like that. So let's just spray this down. And that was definitely the noise, I think. But it just doesn't make sense that the flywheel's so hard to turn unless the starter is pretty messed up, which it may very well be. If that Bendix was out for an extended period of time while the engine was running, likely the bearings might have burned up in there. Well, let's try to tap this, see if we can get any movement and get that gear retracted. Not sure if this sleeve is supposed to move in with the Bendix or not, but I'm going to give it a few light taps and see if we get any movement. And yeah, I think it did move a little. Although it kind of feels like we aren't making progress anymore. So let me tap directly on the Bendix. See if we can get that to move any further. All right, we're in. And yeah, that's a million times better. So the engine now feels like it should. Spins freely. We have that bounce back. So we have good compression. So good. Nothing wrong with the engine. The starter, though, although the Bendix moves nicely now, I'm not sure if the starter does, although I can turn it without issue. So that's kind of odd. So maybe it's fixed. Not sure. The sleeve does move. Interesting. All right, one problem solved. All right, I do want to try this starter now that we've kind of freed things up. The starter recoil, we could repair that. The issue is the blower housing has really only one or two places where it can be secured. And if we try pull starting it manually with the housing the way that it is, likely we're just going to rip apart what little is left. In fact, I think I just found a piece of it right here sitting on top of the ignition coil. So I think electric start would be the best option, assuming it works. But, given the engine rotates fine, I can rotate that shaft without issue, and the Bendix is moving now. I would think it should work. So let's hit the start button and find out. And no, it's doing the same thing. So it's just a really tight connection between this gear and the ring gear. So tight that, I can barely rotate the engine, and the Bendix is stuck like it was before. So yeah, something isn't quite right here. I'm not sure what to think about this one. The ring gear actually looks to be in good shape. I don't see any broken teeth, no excessive rust, and the Bendix gear looks equally good. Nothing's broken or chipped, and no rust. So why they're meshing too tight, I'm not sure. Potentially someone swapped out maybe this Bendix with the wrong one, but I'm not really seeing any evidence of that, because to actually pull the starter, you need to remove that bolt right there, which is behind the flywheel, and you'd have to pull the flywheel off, and things look relatively undisturbed. So yeah, this one, I'm not sure. Potentially we could adjust the clearance maybe by loosening this nut. This one we can access without pulling the flywheel, but I would think we'd have to, loosen that one as well. So let's loosen this one and see if that does anything for us. Otherwise we might have to dig deeper on this. All right, the bottom bolt is loose, and we don't get any movement from the starter. So yeah, no surprise. I mean, honestly, I don't think there is any adjustment on these. I think you just put it on and bolt it down. And the other bolt, not really accessible in the current state. Let's try a little bit of leverage here. No, don't think that did anything. So I just took a look online and found a starter for this machine. The gear is identical, same amount of teeth. So I'm not convinced we have an issue there. So I'm thinking, let's go a little deeper here. Let's pull the flywheel, loosen up that other bolt and see if we can pull the starter away a little bit from its current position. Everything here came off a little bit too easy. That flywheel nut wasn't that tight, and the puller barely had to do any work. So that is what we're after. So let's crack that free. No, that is not budging, so I'm going to try to loosen it maybe from the back side. Okay, and we're loose. At least I think we are. Let's just double check. Interesting. So the nut spun off from the back side. This side doesn't move at all. So I'm not sure what to think of that. And yeah, there's really no adjustment on this. I mean, maybe the tiniest amount. So I don't think we can reposition this. It is interesting, though, that these must be welded on this side, so it's just studs coming out the back. So I guess technically we didn't have to pull the flywheel. Knowing what we know now, I thought these were just going to spin, but that is not the case. So I already pulled the nut on the top side. I just want to pull the starter out, see if there's anything obviously wrong. So what I noticed is that, when I loosen the bolts off, the starter can pivot a little bit, and then the gear has plenty of clearance. So is there something back here preventing this from seating properly? And no, not really. So yeah, not sure what to think about this one. Yeah, so this one's kind of an odd one. I don't see any issue with the starter or the ring gear. All the parts appear to be correct. Don't see anything bent or damaged. And there's only one way to install this. There is no adjustment, no play in the system. Yet the Bendix, it's too close to the ring gear, I would say, by about 10 thousandths of an inch. So, we could order a new starter, but I'm not convinced that'll fix our problem. And this starter here, as it is useless to us. So, I'm thinking we should try to modify it. We really don't have anything to lose. And probably the easiest thing to do would be to drill out maybe the top mounting hole. That will give us a little bit of adjustment and maybe enough clearance to alleviate, this issue that we have here. If that doesn't work, we can probably do the same for the bottom. And with a little bit of fine tuning, we might be able to get this starter to work on this setup. And the other wild card here is, the solenoid. Is it going to let this nut spin out? Yeah, just barely. I would say that was enough force to cause damage, but thankfully that is now spinning, so we can disconnect the positive wire. And we also have this yellow wire with a green stripe, which is likely for charging the battery. Okay, and then the negative wire we already removed. We also have this wire harness right here, which is what connects up to the switch to trigger the solenoid. And it looks like it's just a spade connector that was pretty loose, so we'll tighten that back up later. But at this point, the starter should be free to come out once we finish removing the nuts holding it in. And it is really tight coming off those studs, so that might be a sign of the issue going on here. Something isn't quite right. But the machine surfaces do seem fine, and that's what ultimately aligns it. Anyway, let's open up this hole, see if that helps us out. All right, that's in there pretty good. Yeah, I already double checked the diameter of this hole, the existing one, and it's pretty close, if not exactly 8 millimeters. So it was actually like 7.96. So I'm going to increase that size just a bit. So I'm going to zero this out at the current hole size. And the drill bit that I'm going to use is about 1.5 millimeters larger in diameter. And in inches, I think that's about, 64 thousandths of an inch. And that should be more than enough to fix this problem. So, ideally I would use a drill press or an end mill. Don't have an end mill. I do have a drill press, but there's really no great way to hold this still. So, this doesn't need to be precise. We just need to open this up so that we can make an adjustment. Yeah, it's going to be rough. And I know I'm getting ahead of myself here, but since we have access to the side of the block, let's just take off a layer of dirt. This machine, I might end up pressure washing. I don't like pressure washing generators because I had a bad experience after pressure washing one. A good stator failed during the load test, and that's after I let it dry in the sun for an extended period of time. So it might have just been a coincidence, but introducing that moisture on a machine that potentially had weak insulation was enough to, cause the fault. And really it's not necessary. This is just cosmetic. Machine will run just fine even if it's dirty. But it does look a lot better. Actually shocked how well this cleaned up. I mean, far from perfect, but the amount of aluminum oxide is minimal. And that's one thing I find on these older Vanguards. The quality of the aluminum, definitely a lot better than you'd see on, newer stuff. Yeah, and now we have that adjustment. So it doesn't seem like a lot, potentially not enough, but we don't need a lot. Worst case, we'll drill out the hole on the bottom to the same size, and between the two, I would think we'd be back in business. That might be good enough. Still tight, but before making this adjustment, I couldn't even pull the Bendix manually to get it to mesh at all. And of course, as we saw, once it was meshed, you couldn't really rotate the engine, but now I can. And once the engine starts, the engine spins faster and it should pop that gear in, which it does. So I think I'm going to call it fixed. Let's get the wires reconnected and make sure. And we'll give this one a little squeeze. You can see that spade is kind of distorted. And might have made that a little too tight. Nope, it went on. And definitely not going to fall off. So I'm going to reconnect the battery and we'll try out the modified starter. All right, the battery's reconnected, so we're going to try this in a minute. And what we want to see is that while the starter still works, Bendix comes out and gauges the ring gear, which it did before we fixed it. But the issue was that the clearance was so tight that you couldn't rotate the engine. You could hear kind of the binding of the gears. And then, of course, to get the Bendix back in, we had to hit it quite a few times. And we really couldn't rotate the engine manually. So without the engine starting, the Bendix may not go back in on its own. But let's try it. Let's see what we get here. Yeah, there we go. That sounds a lot better. Bendix comes out and goes back in. So I am going to call that fixed. So now that we can turn the engine over, let's check for spark and compression. And the plug, at least the bottom part, doesn't look great. So we might swap that out as well. Kind of curious to see what plugs in here. You know, Briggs usually uses an RC12YJ, which is kind of what that looks like. But being this was made in Japan, it could be an NGK. If the plug's original. And thankfully that is spinning out pretty nicely, so I don't think we're going to have any surprises as far as rust goes on the tip. Yeah, it is a champion plug. RC12YC. No rust on the tip. Color looks pretty good. Maybe a touch rich. But yeah, this is promising. So let's actually get the spark tester. We'll do the spark test and the compression test, and then we'll get a new plug installed. All right, so keep an eye on the tester. We should see it flashing if we're producing spark. Now, the ignition actually I think is off, so let me turn that on and kill the lights. And let's rotate the engine. See if we have spark both on the plug and the tester. Yeah, nice strong spark. So spark is not an issue. Let's check compression. All right, so the compression, I don't think we're going to see much above 60 because this does have a decompression system, but the starter is spinning it pretty quick, so we might see above 60, but even so, I don't think it's going to be full compression, but we do want to see at least 60. And yeah, not bad. We're actually at 100. Maybe a little bit above. So yeah, plenty of compression to get the engine to start. So get a new plug installed, RC12YC. And these should be pre-gapped to 30 thousandths. I can tell by looking at it. My thumbnail is a good feeler gauge for 30 thousandths, and that is dead on. So we'll spin that down. We do need to put a little extra force on it because the crush washer needs to be crushed the first time you install a plug. And I think while we're here, let's check the valves. This machine is, over 20 years old, and I would doubt they've ever been checked. So if the valve cover comes off without too much of a fight, I think it is worth checking and setting if needed. Yeah, we're loose, but the gasket, I think it's half on the cover and half on the engine, which is not a good thing because I don't think I have another gasket for this. But we are free, at least on the right side. I think it's the top left here that's the problem. Yeah, looks like we saved it. Engine's pretty clean inside. And both valves are tight at the moment, so let's get it to top dead center. And you can do that without pulling the plug out. You just rotate the engine till you feel compression, which is right there. And then you rotate until the magnet is just clearing the coil, which is right there. So in that position, we're at top dead center. To be safe, you should actually go, a touch beyond it. And now we can check the valves. All right, good. We do have clearance on the valves, so can't be that bad. The intake should be 4 thousandths, which a 4 fits in there with a little bit of drag, so that actually feels pretty good. It's actually plus or minus 1 thousandth, so technically if a 5 fit in, we'd be fine. And a 5 fits in with, I would say, excessive drag. And if we're in spec, a 6 should not fit. And it doesn't. So the intake is fine. Exhaust valve should be 6 thousandths, but that's also plus or minus 1 thousandth. And a 6 actually has a ton of drag. So, yeah, I don't think it's any bigger than that, but let's just make sure. 7 does not fit. And let's try a 5. Yeah, and a 5 feels pretty good. So we're a little bit on the tight side, maybe, on the exhaust, and maybe a tiny bit on the loose side of the intake, but they're both in spec, so I'm going to leave them right where they're at. So we've got spark, we've got compression, we've got timing. We just need fuel. So what do you suppose the odds that this crusty carburetor is any good. You know, from looking at the fuel inlet, I'd say the odds are low. There is rust in there. So yeah, hopefully the carb isn't trashed. I think these new go for at least $100 OEM, if not more. So let's get this off. Let's get it opened up and see if it has any chance. So we get this bracket back off. I just threw it on so that the carb wasn't rattling around, but probably not necessary since this bracket is here, which brings us to some of the fasteners on the top. So this one for sure has to come off, and I think there's another on the left side. All right, we got one. All right, we'll set that aside. And this linkage here, I don't think we can remove until the carb is off the studs. Although we're kind of maxed out, so yeah, I don't want to break anything here. You know, we could remove the governor arm altogether, which I kind of hate to do. Oh, no, we got it. Okay. So what do you think? How bad is this one going to be? Doesn't look great from the outside. And when moving around, I think I hear the float moving, but not much. So I'm guessing the needle is stuck. Surprisingly, though, the drain screw is coming out. These commonly break off, you know, if they've been in place since it was new. You know, this machine's 23 years old, and that came right out. So that's actually a good sign, although there is a bunch of debris falling off it. We're going to try the impact on this nut. Yeah, it's spinning out well, although there's lots of white powder falling out. So yeah, I have a feeling we're going to see a lot of that in here. So yeah, a ton of corrosion and varnish on that bolt. And yeah, pretty bad in there. So yeah, not looking good. Although that might clean up. Yep, needle is stuck. And getting this pin out can be a real challenge, even when there's no corrosion. You know, for whatever reason, they fit them very tight, you know, very tight tolerance. And these legs right here, these standoffs, they're really tall and really thin, and it's a common problem for these to break when trying to remove the pin, kind of in the best case scenario, which this is not. So we're gonna have to tread lightly on this. I'm gonna try the automatic center punch and see if we can get that pin to move at all. Yeah, it moved a little bit, I think. Though it's not moving anymore. Let's try it the other way. And this side doesn't really have a flat surface on it, so I'm not sure we're going to be able to do it. So we'll keep going over here. Yeah, it moved. All right, pins out. But the needle is stuck. So I'm going to spray in there just with some penetrating oil, both in the fuel inlet and just all around this area. Sometimes that's enough to release the needle. We also have a main jet right there we can try to get out. It's a tiny little jet. Those also love to strip out. And we have a pilot up here. So let's actually try that first. All right, that is coming out. And I did take a look online. These carbs are actually discontinued. So there are aftermarket options, but they run extremely rich. But you can get an aftermarket carb and use this jet to lean it out. And it actually runs halfway decent. So it's a good thing we have at least that. You know, the clone carbs, they're about $15. But I do have some other OEMs that we can try if we need to. All right, needle is still stuck, but we were able to get the float out. And you can kind of see why. There's just a ton of buildup around there. So we're gonna let that soak first in the ultrasonic before trying that again. Let's see if the main jet is gonna come out. Yep. Surprisingly. So I would say as bad as this carb looks, I think it will clean up and we can get it to run the engine. I guess I'm not sure how well, but it does have a chance. So yeah, let's soak this for a bit, try that needle again, and hopefully we get it out and all this junk cleans out. Gonna give it an extra heavy dose here because the carb's in pretty bad shape. You know, the seller said this machine last ran about 2 years ago, but based on what we found inside, I'm thinking it was more like 10 years ago. Anyway, I did kind of pre-clean the bowl, and I also double-checked the main jet and the pilot jet. Those were surprisingly clear. So maybe it ran 5 or 10 years ago. I'm not sure. So let's give it maybe 10 minutes and see how things are looking. It's only been 5 minutes. Let's just see how we're making out. See if that needle is free. Yeah, definitely still pretty dirty, so I don't think the needle's going to come out quite yet. No. Still stuck in there. All right, it's 5 minutes later, 10 minutes in total. Needle is still stuck, but as it turns out, that doesn't really matter because I didn't realize it at the time, but when I removed the pin, the standoff over here broke. So even if we get this needle out and get the carb fully cleaned up, it's no good. In its current condition, it's not going to hold the float properly, and the needle isn't going to be able to control the fuel flow. So this carb, unfortunately, is out, but I do have two other carbs that actually suffered from the same problem, but have since been repaired. So let's take a look at those instead. And this is the backup plan. So a subscriber about a year, maybe 2 ago at this point, actually offered to repair these. These are the same carburetor off of 9-horse Briggs Vanguards. They came on some Campbell Hausfeld generators, and the prior owner apparently tried to clean the carb like we just did and broke the standoff that holds the pin on both of these. So what Ryan did was he used the end mill to smooth kind of what was left of that leg, and he drilled and tapped and inserted this metal rod, and now the carb is repaired. It holds that pin perfectly. Actually, the pin moves nice and easily, which the original did not, and he did the same to this one over here. So these two carbs, like the one we were just cleaning, were essentially junk until this repair was made. So these have been cleaned up. They've been soaked in the ultrasonic. I've never tried them, but in theory, they should be ready to go, more or less. There is one thing we need to do, actually. The Campbell Hausfeld, we ended up using clone carbs on those, and the pilot jet on the clone was way too rich. So I actually took the pilot from the OEM, threw it in the clone, and that more or less fixed the issue. But that means these OEM carbs actually have the clone pilots in here, which are jetted too rich. So I did order the OEM jets, which are still available. So all we need to do is swap out the clone jet for one of these, bolt the carb on, and we should be good to go. So, these, they are untested. I'm not sure which one's going to run better, but I'm thinking let's go with the one that looks cleaner. So we'll get the bowl back on and swap out that jet. And then we'll bolt it on and try it out. All right, let's try it out. So first we need to connect up the linkage. Gasket's already in place. And we're going to start the carburetor on, but we can't put it on all the way. We need to put on that front plate before fully installing the carb. Pretty tight fit on those studs. So this is the plate right here, and this is the choke control. So there's a little pin that latches in right there, so I think it might be a little bit easier in that position. Got to get that in place like that. And in theory, we should be good, although we're hung up, I think, on the linkage. There we go. And that should control the choke now. We just need to bolt that bracket back up to the governor linkage, and then I will get things loosely reinstalled. I'm not going to put the airbox on yet until I know that the carb is good, and then we can kind of finish things up in this area. So before we start this, I want to see if I can free up this throttle control. You know, usually it's locked in place by these two screws, but they are backed off, and I think we're more or less in the idle position right now. We have to move this to the left, and it doesn't want to move. So let's clean off some of this rust on the threads. And I've already been spraying this with penetrating oil. So we'll clean up the threads. We'll see if we can loosen this up a bit and get some movement out of the throttle control. Okay, it actually loosened up. Kind of surprised. And we can throttle it down. It's hitting the set screw for the low speed and the high screw for the high speed, although that I think is driven in pretty far, because even on the high speed there's virtually no spring tension. So I'm going to back this out if I can, and actually probably just remove it, you know, clean up the threads properly, set it back just a bit. You know, we're not going to set the limit for the top speed until, you know, we get the engine running well. And I might actually tighten this throttle up a little bit too, because we do want it to move, but we don't want it to move on its own. That's pretty good there. And surprisingly, that screw is not locked up. Let's try the other. Yeah, and that one also turns. So despite how bad it looks, it's not bad enough that it won't free up. So everything is moving that needs to move here. So I'm going to buzz that one out, and we'll clean it with the wire wheel and then put it back where it was. And this back one's also been cleaned up just like we saw on the front. So again, we'll just drive that in a little bit. We're not going to be able to set anything though until the engine's running. Okay, I think we're good. So the needle and seat closed and the fuel level is holding steady. And before we try starting this, let's torque the flywheel properly to 60 foot-pounds. All right, let's give this a quick try, see if this thing starts up. We've got a light plugged in and turned on, as well as the kilowatt. You know, the blower housing, we're gonna have to leave off because there's only 4 bolts that hold it on. And the top 2, you know, that metal is broken off. So there's nothing to hold on to the top. On the bottom, these are intact, but the one over here has a broken bolt in the block. So we only have the ability to secure it with 1 bolt, which is not enough. So we can only run this for a couple minutes before, you know, overheating is a concern. That said, though, we shouldn't have to run it for too long to know if the engine runs, if the carburetor runs it well, and if the generator makes power. So the carb, it is fueled up and ready to go, and the battery is reconnected. So let's turn the engine over and see what we get. And one thing I should add here, I don't know what the engine speed is set at right now. You know, we do have the ability to adjust it once it's running. So as it is right now, you know, tension feels good enough to at least get up to a reasonable speed. So let's turn the choke on. Ignition's already on. Contact. Okay, well, the engine sounds perfect, but we had no output from the generator side of things. So the plot thickens. Let's spin this around and see what's going on with the generator side. So on most machines, you really should isolate the stator in order to test it properly. In this case, there is a quick connect, so it makes it pretty easy to do. The pins look decent, actually not much in the way of corrosion. So we're going to test the stator directly through here. And usually, you know, I see about 0.2 to 0.5 ohms. So we want to see something in the ballpark if we can get a good connection. And yeah, about 0.3 seems reasonable. Let's check the other leg. We should see about the same, and we do. Now I'm going to check from leg 1 to leg 2. There should be no connection if the insulation's good, and there's not. And then we want to check it for a ground fault. So I'm going to connect one lead up to a source to ground, which on this machine is easier said than done, but I think down here on the bell housing, you probably can't see it. But I just connected one lead to the bell housing. Let's just make sure we have a connection to ground, and we do. So now we're going to check to each leg. We should not have a connection to ground. And we don't. So the stator, I would say, is good. You know, potentially the rotor has failed, but these machines, their generators are fairly reliable. Really, the only problem I see in them, you know, aside from the occasional meltdown, is a bad capacitor, bad brushes, or potentially it lost magnetism. This one does rely on residual magnetism, but, you know, I'm willing to bet the capacitor. So let's check that next. And actually, before we do that, let's just make sure we have a good connection up here. You know, sometimes people do things in the control panel and end up causing problems. So I just want to make sure we have about the same resistance from neutral to each of the legs. So we'll connect up here to leg 1, should be about 0.3 ohms, which it is, 0.4. That seems fine. Let's check the other leg. And yeah, both those readings are good. So we know that the stator's good, we know that the quick connect's good, and we know that the wiring in here also appears good. So let's check that capacitor. And the capacitor, it's in the N housing here on the generator. This N housing you cannot remove unless you remove the stator bolt. So not really the best design. That said, though, it's also not a terrible design. It's not that hard to do. Now, I do see some rust here, so potentially we have issues with the brushes. And actually, the brushes have to be removed anyway before pulling this N housing off. So let's actually test, see if we have continuity to the rotor, and go from there. So we're going to do more or less the same type of check, except the rotor, it's a higher resistance, usually 40 to 70 ohms on a Honda clone, which this is not. I believe these rotors come in lower at around 25 ohms, but testing through the brushes and potentially dirty slip rings, that could be higher, though in this case, I was going to say we're open circuit, but we're not. Yeah, about 130 ohms. So yeah, definitely on the high side, but not too surprising. You know, likely there is some buildup on the slip rings, making that number higher. So when we get the end cover off, we'll clean up the slip rings, we'll test directly. But so far, I wouldn't say there's any red flags. Let's just check it to ground. Although rotors usually don't fail to ground. And yeah, it would seem like we do not have a ground fault, but let's just double check on a lower setting. Yeah, and the rotor, at least on the surface, appears good. Yeah, definitely some corrosion in here. Wouldn't say it's awful, but it is something to keep in mind. But the brush on the right looks good. And the one on the left, the same. And that blue right there, that is the capacitor that we're after. There's also a couple of diodes in there as well. So, you know, the failure could be the diodes, it could be the capacitor, or some combination of the two. All right, so theoretically, this should come off. Yeah, and whether the capacitor's bad or not, yeah, I guess I'm not sure until we test, but the diodes do not look to be in great shape. So that very well could be the issue here. So let's unplug it. There is a quick connector right here. This is the DPE winding. It's actually 3 wires on this machine. The black wire is the neutral, and then we have leg 1 and leg 2. So it's actually doing full bridge rectification using the center tap as neutral. And then on each side, we have a diode that should only allow the positive through, and it goes to this common bus bar. Okay, we got that off. Let's just double check the rotor while we're here. Make sure that value comes in where we think it should. And we're looking for 25, maybe 30 ohms. Yeah, 37. So that is a good rotor. So there's nothing wrong with the generator unless the DPE has failed, which I guess we can test as well. We should see, on this one, I'm not sure. Usually around 1.5 to 2.5 ohms. In this case, yeah, 1.1 from the center to one leg. Check that to ground, no fault. And we should see about the same on the other leg. And we do. And also no ground fault. So yeah, the stator's good, the rotor's good. The issue has to be the capacitor or the diodes. All right, so let's actually start with these diodes. Given their condition, yeah, I'd be surprised if the failure was the capacitor. So we're going to test from this yellow lead on the left. We're going to send essentially negative in. And I want to see if the connection here, at least to the diode, is good. And yeah, we get a voltage drop down to 0 volts. Now, this bus bar, I was assuming it was positive, but it could be negative. I'm actually not sure because I can't see any of the markings on that diode. So if the diode's working and this is a negative bus bar, we should get a voltage drop. And we do. So that diode right here actually seems to work. And it's a negative bus bar. So if we send positive in, same thing. Let's just check we have a connection on the wire, which we do. And when we touch the bus bar, if the diode's working, we should not get a voltage drop. And surprisingly, we don't. So that diode appears good, or at least not horribly bad. So we'll do the same now on this other yellow wire. We're sending the negative in to the negative bus bar through the diode. We'll test it here, make sure the wire is good. Yeah, and it is. But if we touch the bus bar, we don't get anything. So this diode appears to be bad. And that for sure would cause a no power situation. So I guess the question is it only the diodes that are bad, or is the capacitor bad as well? So to access that, we just remove these 3 screws, remove the plastic plate, and we can disconnect it and test it directly. Although that one's not budging, it was starting to strip. And same thing with that one. So yeah, those are rust jacked in place, which is a problem because we can't really test this. Or maybe we can. We have a blue wire coming off the capacitor that we can probably test right there. And we also have a yellow wire which goes to the bus bar, and it's actually connected to this green wire. So yeah, let's test it like this. I don't want to break anything if we don't need to. This capacitor, it's hard to read, but I think it says 130 microfarad. All right, so let's see if we can get in here. Hopefully you can see that. We'll put one lead here on this green wire and the other lead up here. Now, this probably isn't a perfect test because we do have some things in circuit, but I want to see something around 130 microfarad. And yeah, we're at 121.8. So these capacitors, they're always plus or minus about 5%. So we are technically a little bit out of spec, but at this rating, 122 essentially, the capacitor should work. We should produce power. So yeah, given that the screws are stuck and the capacitor seems okay, I think the big issue here is the diodes. So let's get those replaced and try it again. And actually, I'm not actually convinced this diode is bad. It's certainly in bad shape, but when I was testing for a good connection on this wire, I could get it when I touch the wire. We get a fairly low resistance connection, but when I touch the terminal, connection's not great. At least right there it is. But then if I move down a little more to the actual diode, there is no connection between this spade terminal and the diode. So it could just be a matter of, too much rust. So I'm going to spend a second, clean that up a bit, and we'll do the test again. All right, so now that we have that cleaned up, let's just check the wire again. If the spade is good, if the wire is good, we should get a voltage drop. And we don't. But we do when we touch the wire. And now we do when we touch the spade. So yeah, there might be multiple issues going on here. But it appears the wire is good. And the spade, I think, is good. Let's check the diode directly. So we'll put the negative right here, positive here, and we should get a voltage drop. And we do. Let's try it the other way. So yeah, the diode actually, despite the way it looks, appears to be good. I think the issue was the connection. So let me try to get that wire back on, and we'll test it again from the connector to the bus bar. Yeah, it's still a really loose connection. So it actually looks like this is corroded away and it's missing part of the spade connector. So I think, even though the diode tests well, I think we are going to have to replace it. Yeah, we're definitely going to have to replace it. A part of it just broke off in the connector. So I think I have extra diodes. So let me look for those, and we'll swap them out for some known good ones. So in here, I think we have the same diodes. Yeah, I tested them previously. This is just a good generator that's been sitting on the shelf for a couple years. So the diodes aren't really needed on this generator head at the moment. And I believe this also has a good capacitor in it as well. So if it's the same, we might swap that over as well. So not quite the same as the one over here. You know, the capacitor, definitely a different form factor, likely a different rating, but we do have a bus bar with two good diodes. I think the biggest difference is that, you know, these are soldered on instead of spade connectors, which probably isn't a bad thing because these spade connectors are in pretty bad shape. There's a lot of corrosion. So I'm thinking we should just cut those off and solder them to this diode setup. So let's get this one removed and move it over. So the bus bar, it's just held on actually by the diodes, and we need to loosen up that nut. The diode though started to spin, so yeah, getting these off may not be as easy as I initially thought, although this one is coming right off. So yeah, let's get this one off fully, and I think we'll take the Dremel wire wheel to the other one, clean up some of the rust, and try it again. Let's try the impact first on low. That did it. All right, so in theory, the bus bar should be free. And the diodes are free. So let's cut those wires off. We'll get the bus bar and the diodes out. Yeah, just using WD-40 to clean up the bus bar. It wasn't corroded, it was just covered in dirt. Or maybe a little corrosion, but a lot cleaner than it was a second ago. So let's see if it's the same size. Yeah, it is. So I'm going to get this one off. Or maybe we'll just cut it off. And I think we're definitely going to need the impacts for these. So I'm not too worried about saving these, although technically the one on the left, or actually both of them technically are still good. But I don't think I'm going to be using those again. No, we're going to need a wrench to hold that still. Yeah, there's nothing left of that one, so we can't spin it off, at least not with a 3/8. A little smaller now. So this one, it is rusted out to the point where I can't get a socket on it. You know, the right size just spins, and the next size down won't go on. So we're going to try vice grips, and I think we're going to end up probably drilling this one out. Okay, let's clean this out, and then we'll get the good used diodes into place. So I'm going to have another go at getting these screws out. You know, I'm kind of on the fence as to whether I want to do that or not, because if I break something here, then this whole end housing is bad, and I don't have another one like it. But I did inadvertently pull this wire out, and that's where the brush attaches. So it's extremely difficult to get it back in without pulling this plate off. And if we do pull the plate off, it's actually going to make things easier, because then we can just remove this harness and, you know, solder the wires kind of separate. So I am going to use vice grips, see if we can get any of these to start spinning, and then we'll spin it out the rest of the way with the screwdriver. So this one here, I already broke free. It's pretty crunchy, but it's coming out. So once we get them all out, I'm just going to blow kind of the rust bits out. And when we put this back in, we'll use just a little bit of penetrating oil to help both with reinstalling, but also, you know, helping someone in the future to remove them if needed. All right, that one's turning. And so is that one. So they weren't too stuck. I just think that, you know, this type of tool, you know, would have been better if it was just a bolt rather than a screw. You know, the Phillips screws, you can't put a lot of torque on them before they strip out. But in this case, we saved the screw, and we got him to come out. All right, so we're going to have to be careful. Diodes can be destroyed by heat, and the tip of this has a lot of heat in it, but you know, we have to do what we need to do to get the wire off. And once it's off, I'm going to let it cool down. We'll clean it up as needed. And then do the same for the other diode. Yeah, we melted the solder that time, but the wire is twisted in such a way that we just can't pull it out. So I'm going to trim that a little shorter after we cool it down. Come on. So it looks like everything's intact. Let's just test it, make sure it still works. In this configuration, we should get a voltage drop, and we do. And if we switch it around, and now we try to send power the other way, we should not get a voltage drop, and we don't. So this diode survived the process of cleaning it up. So let's do the same to the last one. And hopefully we end up with two good diodes here. All right, let's see if this one survived. So in this configuration, we should get a voltage drop, which we do, but if we reverse it, we shouldn't get a voltage drop, and we don't. So good. We have two good diodes. So let's get them installed on this harness. So we're going to try the smaller iron again. I'm not sure it's going to have enough to do it. And no, small one, not really up to the task. It's just wicking the heat too quickly away. Of course, the big one might have the opposite problem. That looks good. All right, we'll keep this side loose for now until we get the other side installed. So we need to attach the green wire, both of them, through the diode. And then through the bus bar. And I'll just get the nut started. You know, we need to situate these wires a little better before we tighten things up. And I think this will be good. These wires, or this harness, I think originally was tucked up under here. This blue wire, that is the positive brush. And the green, the negative. So actually, let's get the capacitor in place first. I think we'll run the wire on top of those. And that should be good. So let's get the plastic plate on to hold everything in place. And then I think we'll be in a good position to get this back on and try it out. And while we have access, I'm going to get a little bit of grease on this bearing. Then we'll get this cover in place. And all these were cleaned up. So I took the wire wheel to them, cleaned the rust off, and put a little bit of penetrating oil on them. And last but not least, we'll get the brushes reinstalled. Got to be very careful not to lose these into the housing, which I did at some point when putting this back together. So I actually had to pull this back apart, pull that plastic plate back off, and feed that wire back through. So that one is good. That one's also good. So I'm going to leave the cover off for now until we know this is fully working. There's really no point in putting that on. These bolts that hold the brushes in, I did clean the rust off and put a little bit of penetrating oil on the threads. All right, so let's try this again. Now, even though the old diode technically wasn't bad, it was rusted and there was no connection. So we weren't getting a full rectification of the power from the DPE into the field, and that was not enough to power this up. So now both diodes are good. They're making a good connection and the field should power up. I guess the one wild card here is that this has been running with a damaged diode, or one that wasn't making a circuit. So the field wasn't powering up, loads were connected. That can cause a loss of residual magnetism, and just sitting for a long time can also cause a loss. And this one I would say has been sitting for quite a while. So what I'm trying to say is we might have to flash the field, but let's start the engine, see what we get. And no power. So the easiest way to restore magnetism on a machine like this is just to energize the brushes using DC. So I have a 12-volt battery, and the positive lead here is going through a fuse just in case something goes wrong. And we're just going to touch this, energizing the field for about 4 or 5 seconds. And that should be it. But if you want to make sure, do it a few times, and you should see a spark. In this case, I do. So that power definitely went into the rotor, and that should restore magnetism if that is the issue. Okay, we're topped off on fuel. So let's try this again. Based on all the testing, this should work. Residual magnetism is really the last thing here. So hopefully this time the light comes on. Contact. And there you go. It makes power. So this one had me a little bit worried, but based on all the testing we did, there was really no reason why this generator was not capable of making power. And it was a combination of things. Obviously, the engine had some pretty major issues. The diode had an issue, and we had no residual magnetism in that generator. So now that all that's been corrected, the generator is making power. The engine sounds good, and surprisingly, the engine speed is almost perfect. It was just over 60.5 Hertz. So we haven't really fine-tuned anything here, but given that we're close, I'm going to set the idle speed right up against the stop, and the high speed, I'm going to drive it in most of the way. I think we might have to fine-tune it a bit, but where it is pretty close. Before we move on, though, let's get the oil changed. You know, this one has definitely earned it. Yeah, we're right at the full mark, so I think we're good as far as the oil goes. And the oil that came out, you know, besides being well used, doesn't look bad. You know, I don't see any gray metallic in there, no glitter. So the engine, it's in good health. And as far as the rest of the machine goes, you know, it's far from perfect. You know, the frame actually isn't that bad. I mean, there is some surface rust, although I think a lot of that's just dust. So the frame could be better, but I think I'm going to leave good enough alone. The exhaust, though, and the valve cover, you know, I think that should be painted up. Your eye kind of goes to that, and this is obviously rusted pretty bad. So I think the determining factor here are these nuts. They are rusted pretty well. So I'm going to try to loosen those up. And if they loosen up, we'll paint it. If not, we're going to leave good enough alone. No, that one's not coming out. And I was using more force than I'd like. Let's try this one. No. So could we get these out? Potentially. But at what cost? If we break the studs, you know, we're just creating more problems for ourselves just to make it look pretty. So I think I'm going to call this good enough. You know, it's not a new machine, and it's going to have a bit of rust on it. As far as the blower housing goes, I did order up a good used one. You know, the one that came on this machine has the 2 broken tabs on the top, so we can't secure it. We have a broken bolt down there, so we can't secure it, and only one right there. So with the new blower housing, we'll be able to secure it using 3 of the 4. Potentially, we can make it 4 for 4, but this bolt looks like it broke off a long time ago, and it's recessed in there. So, you know, originally I was thinking about welding a nut to it, but in this case, I don't think that's going to work. You know, we could try a screw extractor as well, but I think the easiest way to go here would be just to drill it out with some left-handed drill bits, and most likely we'll just end up tapping it out. But, you know, using a left-handed drill bit, potentially it could spin that out, and then we don't need to retap the threads. And it's going to be hard to drill this one out too, because the bolt that broke off, it didn't break off flat. So when we put the drill bit on there, it's going to want to walk around. So I'm going to use the smallest bit I have. You know, likely it's going to go off center, so we're going to have to counteract that. And once we get it back in the center, we'll try to go as straight as we can, and then use a larger drill to get it to the right size so we can tap it out. Yeah, I think that's it. Bolt's only that long, and I think we're that deep in there. So I'm going to call that good enough. Now we just need to drill it to the final size and tap it out. And the final size is going to be 5 millimeters, which I don't have, but I do have an 11/64, which is pretty close to the same. Might be too tight. Let me double check that drill size. No, it measures 5 millimeters, so that tap comes to a very hard stop. Ah, got the old threads out. Yeah, this might be a lost cause. I'm not sure what happened here. So the hole I drilled was 5 millimeters. Or to be more precise, 4.8. So it was actually a little small. And the tap, I assume this is a 6 millimeter based on, well, what it says on it. And yeah, it is. And yet, it seems like it just pulled the threads out, which I'm not sure if that's actually the case, because I did run the left-handed drill bit in there again and pulled out, looks like the center section of the old bolt. So how is that now wider than 6 millimeters? Not sure. So on this one, I think we're going to have to go up to the next size. So I'm thinking we might go to a 1/4-20, which is kind of the next size up. And that gets tight, you know, as it cross threads. So we're going to run the 1/4-20 tap in there and hope for the best. Yeah, that should be good enough. Well, it's a few days later, and the used blower housing from eBay has arrived. This cost me $45, and although these are the same age, you can see the replacement one is in a much better cosmetic condition. And more importantly, we have all the bolt holes to secure this properly to the engine, whereas, well, yeah, the old one didn't. So this one is out, that one's in, and a little added bonus is that the tag on this replacement one has the same model and type code as the blower housing that we're replacing. So if anybody needs to look up parts in the future, they'll have the right information. So let's get this bolted onto the engine. And the bolt here on the bottom right, I can tell you already, it's not going to torque down to 60 inch-pounds, so I'm just snugging it up and calling it good. And we're going to reuse this filter. It's not in that bad a shape. And costs, you got to keep that in mind when working on this stuff. Even though this was only an $85 machine, you know, at best, you know, I think I could get $250 for this. And we already have about $75 in the battery, about $50 in the blower housing, plus the cost of the machine, the oil. You know, right there, we're approaching $200. So, yeah, there's not a whole lot left in the budget for this machine. And as far as the starter goes, you know, I think we just need to put a new end on. You know, it broke off. We don't have the handle, but I do have another. You know, the mechanism itself is probably fine. And I guess the question is, you know, how much rope is left. So let's actually feed this through. If we can. We might actually need to cut this first and just clean it up before we can get it through that hole. Yeah, and actually this rope, it's not in great shape. It's kind of frayed, a little bit dry rot. So I think the better action here is to just remove it and start fresh. Yeah, and it was also pretty short, so we would have had to replace it anyway. So we'll pull that out. We're going to wind this up. Pretty much all the way. Which I'm going to call that good. And then we need to locate the hole. So the hole is right there on the rail, and the rope comes in right there. So we need to back it up a bit to about there, lock it in, and then we can feed in the new piece of rope. And actually, let's move this out of the way because we got to tie the knot right there. So we'll put it then I just wind it in, let the spring do the work, and I stop either when we lose spring pressure or there's just too much on the reel and things start to bind up. And it looks like spring pressure is pretty weak at this point, so I am going to put that screwdriver back just to make sure. We don't want to lose the rope once we cut it. And we need to melt this a bit to keep it from fraying and make like a little tip so that we can feed it into the handle. And for that, we're going to use this handle right here. I'm not sure what it's from, but it seems like the right size for what we're trying to do here. And actually, I think we do need to take a little length off. Spring tension's pretty weak right now. So I think there might be a little better. Yeah, I mean, this will work, but I'm just realizing this recoil, it's expecting kind of a taper on this side so that it centers up nice. I mean, not a big deal. We could use this, but let me take a look around, see if I have anything a little more appropriate for this engine. And now I think this is as good as it's going to get. Not ideal. You know, this I believe was meant for more of a Honda clone, where it seats kind of in the inside. Whereas this one's kind of the opposite. It's expecting one that is tapered to kind of go in instead of around. But yeah, not the end of the world. It'll work. And although we're not painting it, we can at least make it a little safer. And the last big obstacle here is the tank. So as it is right now, we have a cracked bushing. We have a valve that does turn, but nothing flows out of it. So either the valve is clogged or the line. You know, either way, we're going to put a new valve in, a new bushing, and I think I'm going to pressure wash this tank first because it is a complete mess. All right, the tank looks 1,000 times better. And there's no real easy way to get this valve out. You just twist and pull. You might need a screwdriver to pry a little bit, but you don't want to get carried away. I mean, this is a plastic tank. You could cause damage, but the fact that the bushing is already deteriorated might make this a little bit easier. Yeah, that wasn't bad at all. So I'm going to set this aside. We're not going to reuse that. And we're going to use this part. Very similar to what was in there. Actually almost identical. Got a brand new bushing, new valve and filter. And you just put this in, and then use a little bit of oil or soapy water on the inside of the bushing and the valve. And then it's pretty much the same process in reverse. You just twist and push until it seats all the way in. And that's it. It's so tempting to pressure wash this because you can see the engine, it will clean up. But it's not really worth the risk to the generator. All right, so now that we have the tank reinstalled, I'm going to add some fuel to the tank. Not too much though, just in case it leaks, but we'll give it some time. I want to make sure the new bushing is holding and that we don't see any leaks down there. And I'm also going to leave the fuel line disconnected from the carburetor so that we can see if the valve actually works and can hold the fuel back. Yeah, so far so good, but it's only been a few minutes. And I'd like to give it a few hours just to make sure. All right, it's actually been about 3 days that I've let this sit, and everything is nice and dry, no leaking from the valve, and the valve is holding the fuel back. So we're going to get that fuel line reconnected, and that just brings us to the cap. Now, the cap, it is a discontinued part, and I cross-referenced the number, came up empty, so instead I ordered this cap, which is for a John Deere STX tractor. It looked to be the correct part, although the measurement on it was a tiny bit smaller, so I'm not sure if this is going to fit, but I'm thinking worst case, it does have the seal we need, so potentially we could move that over. Anyway, let's get the fuel line connected, we'll see if the cap fits, and then we'll get it outside for a load test. So you can see the parts, they do look the same. Question is, are they the same? You know, the outer diameter is the same. I believe the inner diameter is a little bit tighter on this one, but this one has the rubber seal, whereas that one, it is gone. So hopefully this is gonna fit. And yeah, a little bit snugger on the threads, but it does fit and it tightens down properly. So I think we're good as far as the cap goes. All right, so let's give this machine a try. Now this is rated at 5,000 watts, and powering it is a 9-horse Vanguard engine, which can only do 5,000 watts, assuming everything is running perfectly. And I guess the one thing we have to our advantage is that this generator, it does not have an automatic voltage regulator. So what that means is that without a load, the voltage is going to be high at about 128 volts. And under a full load, we're going to lose about 20 volts, and that should come down to about 108 volts fully loaded. So even though we're applying a 5,000 watt load, according to the labels on the load bank, when you take into account the voltage, we're actually going to be falling a little bit short. So I might go for a little bit more, maybe 5,500 watts according to the labels, and just make sure it's up to the task. So I'm going to get the engine started. You know, while it's warming up, we'll double check the output using the kilowatt to measure the voltage and the frequency. We use the amp probe to measure the total harmonic distortion in the oscilloscope to see what the sine wave looks like. You know, assuming everything checks out, we'll put on a half load, we'll give it some time, and then we'll go for the max of 5,000 watts. All right, no issues at all. The engine started right up, sounds really good. And the generator output is pretty much where we thought it would be. We're at about 129 volts, 61 Hertz, which is pretty much perfect. Now, I wish I could say the same though about the output as far as the power quality goes. You know, we're starting at about 12% THD, and the sine wave not looking very good. So hopefully that smooths out a bit once we apply a load. So let's start with 1,000 watts. No issues. Let's double that to 2,000 watts. And then we'll bring that up to 2,500 watts. So engine speed looks pretty good. THD mostly unchanged. We're at 12.6%. And the sine wave, well, it still doesn't look great, but it does look better than it did before. So let's give this a few minutes, and assuming everything looks good, we'll go for the max of 5,000 watts. Well, so far so good. You know, the voltage did come down by about 10 volts at half load, so that's pretty much where we expect it to be. Engine speed also not bad at about 59.5 Hertz. So let's bring the load up some more. Let's go to 3,000 watts, 3,500, 4,000. The engine definitely working pretty hard. So I'm not sure it's going to take a whole lot more, but let's try. Let's swap these lighter loads. We'll go back to 4,000 watts. How about 4,500? 5,000, according to the labels. So it's doing it. Under that kind of a load, THD came up quite a bit. We're at 17.2 and the sine wave, yeah, doesn't look great. but better than where we started. So let's give this a few minutes, and then we'll go for an overload, see how it does. Well, it's been a few minutes. Everything's running kind of as expected. We're at 108 volts, so the voltage has come down. The engine speed also seems to be pretty close to 57 Hertz. We're actually at 57.5, and really you want to stay above that. So I think the engine is just about out of power, but let's give it a little more. So let's swap these lighter loads back to 5,000 watts according to the labels. Let's try 5,500, 6,000. So, yeah, I'm not sure we're really producing a whole lot more as far as power goes. You know, we're only pulling, I don't know, maybe 21 amps at maybe 210 volts. So, yeah, I think we're definitely at the max as far as what the engine can do and the generator. So, under an overload condition, THD came up some to 18.7, and the sine wave looks mostly unchanged. So we're going to call that a pass. You know, for what it is performing like it should. So with the load off, we'll give it a few minutes, we'll let things cool down, and then we'll shut it down. All right, guys, and that is pretty much it. So this machine lives again. You know, things weren't looking too good in the beginning, but we got through the engine issues, we got through the generator issues, and now this thing is back up running and making power like it should. So, I hope this video helps someone. Thanks for watching.